The telegraph operator designed a codebook optimized for English, but today's message is in French. The letter frequencies are different. Some codes are too long, some too short. The message costs more to send than necessary. That extra cost is the Kullback-Divergence. The divergence, Kullback-Leibler divergence, measures the extra cost of encoding messages from distribution P using a codebook designed for distribution Q. Decl of P from Q equals the sum of P times log of P over Q. It's always non-negative. 0, only when P and Q are identical. And it's not symmetric. The cost of using Q's codebook for P's messages is different from using P's codebook for Q's messages. Kullback-Divergence is not a distance, but it measures how different two distributions are. In scVI, the variational autoencoder for single-cell RNA-seq, the loss function has two parts. The reconstruction loss measures how well the decoder rebuilds the gene expression from the latent representation. The Kullback-Divergence term measures how far the learned latent distribution is from a standard normal prior. Without the Kull term, the encoder could memorize each cell. Perfect reconstruction, but no generalization. The Kull regularizer forces the latent space to be smooth and organized. This is why SPI's latent space is useful for clustering and batch correction. Decision trees split data to maximize information gain. The reduction in entropy after the split. Parent node entropy minus the weighted average of child entropies. The split that removes the most uncertainty wins. A split that perfectly separates the classes reduces entropy to 0. Maximum information gain. Random forests make thousands of these splits across hundreds of trees. Each split is an information theoretic decision. ARACNE algorithm for the reconstruction of accurate cellular networks compute mutual information between every pair of genes across hundreds of samples. HIME means the two genes share information. One predicts the other. But HIME between A and C might just mean both are regulated by B. The data processing inequality says, if A regulates B regulates C, then me between A and C is less than or equal to the minimum of me between A and B and me between B and C. ARACNE prunes the weakest edge in every triangle. What remains? Direct regulatory relationships. Gene regulatory networks from information theory alone. Cross-entropy connects information theory to machine learning loss functions. H of B, Q equals H of P plus decl of P from Q. When training a classifier, the true label distribution is P, and the model's predicted probabilities are Q. Minimizing the cross-entropy loss, minimize the Kullback-Divergence between predicted and true distributions. Log loss in logistic regression is cross-entropy. Every time you train a neural network with cross-entropy loss, you're doing information theory. Entropy measures uncertainty. Mutual information captures all dependence. Kullback-Divergence measures the cost of being wrong. Cross-entropy links them to machine learning. Information gain builds decision trees. ARACNE infers gene networks. SPI regularizes autoencoders. The telegram operator's toolkit, invented by Shannon in 1948, runs modern computational biology.